Example 1, state the transformations that need to be applied to obtain the graphs of the following functions from their parent functions. So in part A, the first thing we need to do is identify what the parent function is. So pretend as if the numbers aren't there and see what you're left with. If we remove 3, -2, the 4, and the 9, we'll be left with the parent function y is equal to f at x. Okay? The numbers actually represent transformations. So 3 in this case is taking the place of a. And then the number that's just before x, that's taking the place of k, so k is -2. The number that's being subtracted from x is taking the place of d, so d is 4. And the number at the very end that we see is taking the place of c, so c in this case is 9. Okay. A is responsible for vertical stretches and compressions and also reflections in the x-axis if it's negative. Since A is a positive 3, we don't have a reflection in the x-axis. And since it's greater than 1, we have a vertical stretch. So the first transformation is a vertical stretch by a factor of 3. K is responsible for horizontal stretches and compressions as well as reflection in the y-axis if it's negative. So since K is -2, we have a reflection in the y-axis. And then since the absolute value of 2 is greater than 1, we have a horizontal compression. The horizontal compression will be by a factor that's a reciprocal of 2. So the reciprocal of 2 is 1/2. Okay, when you are stretching something, you're making it bigger. So multiplying by a number like 3 will result in a larger, bigger answer. When you're compressing something, you're making it smaller. So multiplying by a number between 0 and 1, like 1/2, results in a smaller answer. Continuing with the transformations, D is responsible for horizontal translations. Since 4 here is positive, we have a horizontal translation 4 units to the right. Okay. And then C is responsible for vertical translations. And since it's positive, it's going to be a vertical translation 9 units up. Okay, let's look at the next example. First, we're going to identify the parent function. So if the number is 4.5, and then this number, that's actually -1 that's being subtracted from x, and the -2, if they weren't there, it would be left with x in the denominator with a 1 in the numerator. So this is your reciprocal parent function. The numbers 4.5, -1 and -2, or -1 and -2, represent transformations. The 4 is taking the place of A. K is going to be 0.5 because it's just before x here. D, which is the number that's being subtracted from x, is -1 for us to see that +1. So that's our D value here. And then the number at the very end is taking the place of C. So C is -2. And based on these values for A, K, D, and C, we can write down our transformations. Again, A is responsible for vertical stretches and compressions and the reflection in the x-axis if it's negative. We don't have a reflection, and A is again greater than 1, so we have a vertical stretch by a factor of 4. K is responsible for horizontal stretches and compressions and a reflection in the y-axis if it's negative. K in this case is not negative, so we don't have a reflection like we did last time in the y-axis. And the K value is between 0 and 1, which means that we have a horizontal stretch. And the horizontal stretch will be by a factor that's a reciprocal of 0.5, and the reciprocal of 0.5 or 1/2 is 2. So we have a horizontal stretch by a factor of 2. D represents horizontal translations. Because it's negative in this case, the translation will be to the left. So we have a horizontal translation, 1 unit to the left. And then C is responsible for vertical translations. Because it's negative, the translation will be down. So we can write a vertical translation, 2 units down. Okay. Let's look at a second example here. And in this example, we have to write the equations that would result from applying the following transformation. So we're given the transformations, we're given the parent function, and we have to write down what the resulting equation would be. So in part A, we have a vertical stretch by a factor of 3, horizontal stretch by a factor of 4, horizontal translation 6 units to the left, and a vertical translation 3 units up applied to y is equal to the square root of x. So it's the parent square root function. So the very general form with the values of a, k, d, and c would look like this. It would be y is equal to a, followed by the square root of k times x minus d plus c. So looking at the transformations, we have to identify the numbers that will replace these letters. So if we have a vertical stretch, that's represented by a, and the vertical stretch is by a factor of 3, so a will be 3. Next, we have a horizontal stretch by a factor of 4, and k represents horizontal stretches. Now, you won't see 4 in place of k, you will see the reciprocal of 4. And the reciprocal of 4 is 1/4, or you can write it as a decimal of 0.25. There's also horizontal translation, and horizontal translations are represented by D. Because it's 6 units to the left, that means we're subtracting a negative 6. So if you subtract a negative number, it's the same as adding a positive number. So inside the brackets, we would see x plus 6. If it's a horizontal translation, 6 units to the left. Okay, and finally, we have a vertical translation 3 units up, and vertical translations are represented by the C. And since it's up, it means that we're going to be adding the 3 units at the end. So this would be the resulting equation here. So here we have a reflection in the x-axis, a horizontal compression by a factor of 0.5, and a horizontal translation 8 units up to the right applied to the absolute value function. So if we write the general form with the variables a, k, d, and c, we would write y is equal to a, absolute value of k times x minus d plus c. Now we're going to substitute in the numbers for a, k, d, and c. If we have a reflection in the x-axis, we know that that would make our a value negative. Okay, we don't have any vertical stretches or compressions. That means the absolute value of a would still be 1, but we're going to add that negative due to the reflection. So we have -1 to start. And we have a horizontal compression by a factor of 0.5, so k is responsible for horizontal compressions. And what we would see here is the reciprocal of 0.5. Reciprocal of 0.5 or 1/2 is 2, so we're going to have 2 in place of k. Next, we have a horizontal translation 8 units to the right. Horizontal translations are represented by D. Since it's to the right, D is going to be positive, so we're going to be subtracting positive 8 from X. And we don't have any kind of vertical translations. That means that C would be 0. So we don't have to write plus 0 here. It would be implied.